Well, hi, good morning, and welcome to my shop. Thank you so much for joining me here. It's March 11th, not far from the Ides of March. Well, at the end of the video yesterday, after replacing some more capacitors, I operated this radio, and the result wasn't really what I was hoping for. The result really wasn't that good, but I'm not going to worry about it. I'm going to continue with the capacitor replacement. We have 1, 2, and 3. This one over here is the tone capacitor. So we have these two. I wonder what they're doing in there. Could they have some influence on the operation, significant influence, or could they be an explanation for why the radio didn't operate? Normally, when you're fixing a radio up, it gets better and better all the way along, but not always. Or it could have just been something about what I was doing yesterday, how I was doing it. Who knows? Okay, so we got this capacitor and this one to look for. Let's start with this one. So it's on a terminal strip here, which makes it a little bit difficult. Some wires that are twisted going to the volume control. Also have some wires coming out to the switch here. So the switch is selecting either the phono input or the radio input. So we can guess phono input is this, the radio input is this green. The radio circuit output is on this green wire heading to the volume control through the switch here. Okay, that doesn't help us know what this capacitor is though. So this capacitor is tied to a particular spot there. It seems just a little dark in here. Okay, oh, that reminds me, my cat is outside. My cat's outside. It's -3 outside right now, and there's snow on the ground, just a dusting of snow on the ground. She won't be wanting to stay out there very long. I'm going to have to remember. Let's go back to looking here. So I do see something interesting there. I'm going to have to get the other camera and look at what's going on, because there's something could be a little out of sorts there actually. Let's take a look. Once again, I haven't turned on, the automatic focus is on, so I'm looking down here, and what I'm seeing is, what's that piece of wire there? It's under the red wires. Is that just a cut? It is. I can see the end of it. Well, it looks like somebody put a component in here and then never cut away the excess lead wire and just left it, and I guess couldn't see it. But it's not touching the chassis there. It's just hard to see it here. So there's the end of it there, just hanging in. Come on, focus. Yeah, just hanging out there. Ho, ho, ho. That's probably right from the factory. This doesn't look very good at all. Come on, camera, stay focused. Only one of us is allowed to drift off. That's me. You have to stay focused. Come on, camera. That's why I just really dislike the automatic focus here. So, well, it's soldered, but let me get in there and get a grip on that wire. So it's not too often you find something like this in a radio right out of the factory. You can see somebody clipped the other wire, the one that's right here. But nobody clipped that one. Okay, so what? So look, we're looking right at the tube socket now. We should get a look at the. I'm looking for the key on the. Yeah, I cannot see it. Okay, so what I'm going to do is we are going to carry on with which capacitor? With this capacitor here. Let me switch cameras again. Carry on with this one. Oh, you know what? Let's flip back to that camera. I think there's more wrong there than what I thought. Okay, I'm gonna rock the. See the wire go to? You know, if this is soldered in, then the wire that's sticking out wouldn't move. This component was put in and never soldered, or soldered so poorly that it's come loose. Wow. What about the other end? The other end's okay. That's an unusual thing to find in a radio. A failure to solder a part. Huh. Well, it's coming out anyway, so no need to solder it. Hey, saved some solder there on that part. Don't know if I just pull it back out of there. I don't think so. I still have to nip the wire. Okay. Read. Get this out. Come on. Yeah, there it goes. Clip lead to mark where it came from. Knock it out of here. Still don't know what this is exactly. Knowing the size might help a bit. 0.02. 400 volt capacitor. Okay, I'm going to find this on the schematic and we'll consider what job it was doing in the radio. Okay, so I've replaced this capacitor. You can see the replacement. A little hard to see, a little green guy just in here. It took me a long time to sort out what this capacitor is, and maybe it shouldn't have. It's connected to this wire, this red wire, which goes right to the center terminal of the volume control. Should have been easy to figure it out. This is the capacitor that all the audio passes through when it first comes out of the volume control after coming out of the radio and being detected. So at this point the audio is on its way to the first amplifier and then eventually onto the power output tube. If this capacitor can't pass any signal, you wouldn't hear anything. I mean, all the audio is going through this. Well, we certainly heard audio on this radio, so I mean this can't be completely shot. I already have the replacement in. Let's put this guy on the tester here. Let's see what we get. This is not a hard working capacitor. It's not subjected to a large voltage. It's really got a pretty light duty. Let's see what happened to it. Okay, 50 volts, watching the eye. She's not coming open. She's not coming open. So, with this one leaking, we'd have to look at the schematic, and the schematic's hard to look at, but in many cases, this is the only capacitor blocking DC from getting from the detector side of things with the AVC voltage that's there all the way over to the grid of the first amplifier, the preamp, to the preamp grid. So a little bit of a leak in here could, I suppose, affect the bias on the detector tube triode. So it's out and gone. I'm not going to operate the radio because I'm pretty sure it's going to work the same. Famous last words. I'm going to go after this one next. So first I want to try to identify this. What's it doing here? So it's connected to a terminal strip along here. This terminal it's connected to is following this wire up to this coil. The other side is going to ground. It's connected to this terminal on the tube, but can you see that the terminal is actually soldered to the chassis down there? So this is just finding a place to go to ground here. So grounded on one end, and the other end is connected to this coil. Now what's this coil? So this could be the oscillator coil, it could be the antenna coil. It's right near where the antenna is coming in. This is actually the antenna wire right here. And the switch, so it's probably an antenna coil. Then mounted at, see this coil here is mounted at right angles. They're mounted, one's this way and one's that way, so the two of them won't affect each other. Look, here's another coil here. So I'm going to guess antenna coil, shortwave, broadcast, something like that. This is the oscillator coil tipped on another angle. They're all located close to the switch. The switch is affecting the antenna coil, probably selecting which of these two transformers to operate. One for broadcast and one for shortwave. I've looked for this gimmick here on the schematic. I haven't found it yet. Sometimes these things are drawn pictorially so you can spot them. Other times they just show them as another capacitor, because electrically it's just another capacitor of maybe a 2, 3, 4 picofarad capacitor. Don't want to touch that. Move it, bend it, twist it, do anything to it. When they make the radio, the reason they do this, or one of the reasons they do this, when they build the radio, they will wind this wire around here, and then they will check something in the radio, have some instrument running or something, and they will unwind it and nip it, unwind it and nip it until they get the proper reading on this instrument, whatever it might be they're doing. And that's how they adjust this. They actually nip back this wire here. Okay. So you know, why would they do that? Well, they're compensating for varying factors in the radio construction. They can't, you know, not every radio is built exactly the same. Not every part is exactly the same. Not these coils are exactly the same. They're all a little. There's a variation, of course. So you must compensate for the variation. That's what adjustments like this is. And these two up here, these are, and there's one more right here. And these are things that are adjusted once at the end of the factory process to tune the radio up, considering the fact they cannot be identical. They cannot be so identical. And little things like positions of wires and stuff like that can have an influence on the radio's operation. So you can't control that stuff in a factory 100%. So, okay. So I'm trying to identify this aren't I? And yeah, so one coil, we'll figure out, this has got to be, I don't know what it is. This has got to be, I don't know what it is. And let's look on the schematic. Maybe we can sort it out there. Of course, you might just get more confused looking at this. So again, capacitor whose value I cannot see, and connected to a coil. So it's at the other end of the radio. It's down this way. That's where the coils are. So here we see L1, L2, L3, L4. So they're identifying 4 coils in here. Let me just show you one that's really interesting I noticed earlier. Look at this little guy right in here. What is this doing? So there's a capacitor here and a little coil. What's it doing sitting there? It could be that this coil is influencing this one. What is this? C7. So the hint is down here. C7. IF rejector. IF rejector. IF rejector right near the antenna. So I think the objective of the rejector, the objective of the rejector is to trap out, coil, or block the IF frequency from getting to the antenna or coming in on the antenna. Commonly these are called traps because you can think of it that way. It's a trap. It's trapping a certain frequency to not let it get by here. So that's what's going on there. Thought that was interesting. Not all radios have a IF trap in them. Now, what was I actually doing? Oh yeah, I was trying to figure out the capacitor. And so even though this is L4 and L3, they may be wound together on one tube, so they look like one coil. Likewise for these, but there's 3 coils. Is there a guide by any chance in this schematic? I don't remember seeing one. No. There's another page to this schematic information. Maybe something on there to help with this. Connected to one coil. How can we tell? Well, we can maybe, I was going to say by the number of wires going to it. That doesn't help. Can we trace the antenna? The antenna goes in the switch. A little tricky to trace it. If it were coming out on either of these 2 wires. Okay, so the antenna appears to be switched between the 2 similar coils. That leaves the 3rd one that the capacitor is connected to. The capacitor is connected to these coils. These are oscillator coils. That could be it right there. Is it? Well, no. C5. C6. They're all going to ground like that. C5 or C6. C5, oscillator trimmer, oscillator pad, or no, these, no. See the little arrow they've drawn on here? That's to indicate these are adjustable. So these are not fixed capacitors. Can't be, could be this, C10, 0.05, 200 volt. That's probably it, right there. Oh, it's connected to this coil. Well, I could have this all mixed up. What else can it be? There's nothing else in here, is there? These ones, I've done these already. This guy, C11, I think is a, it's a mica capacitor. We're not doing that. Mica capacitors are very reliable. C10. It must be C10, so we expect it to be a 0.05. Okay. And what's it doing? What's it doing here? See, this might be tough to say. It looks like it's applying a ground to this line here. What is this line? So this line looks like, oh my gosh, C10 is the AVC capacitor. So we follow this up. We see we're going by the volume control here. So we're starting to get into the audio area of the radio. Just a second. Turn off my capacitor checker. Oh, I didn't. Don't say that. He's muttering and mumbling. Okay. So here, where the signal's coming through the radio, at this point it encounters these diodes here and gets rectified. So the signal has been rectified. The rectified signal allows the radio to detect, hear, or work with the audio signal that's in the radio signal after detection. And that audio is sent off this way. In the meantime, doing this generates a DC voltage. And it can be a positive or a negative. This will be arranged so that there's a negative voltage building up here. And you can use that negative voltage by sticking it on the grids. Grid. Sticking it on the grids of these first tubes. And this is the AVC. So this voltage depends on where the switch is thrown here. Well, I'm not quite sure not clear what's going on here. Well, this capacitor is sitting on this AVC line. Now, this controls the automatic volume control response very much. Bigger capacitor, the response is slower. Small capacitor, response is faster. So that's it. That's what it's got to be. C10. Enough talk about this. 0.05. Let's find out. 0.05. Get my pens. I looked away. I was going to this grounded terminal here. Grounded? That's a bad word. We use that word in North America a lot, and it's really not the best. So 0.05, where are you here? 0.05. Bingo. Okay, so that's what this is. This is the AVC capacitor. Just picking the wax off at the lead. Well, let's give it a test. This guy's leaky. It's not good. He's in part of the radio that doesn't have a large charge of electricity in it to make it operate. It has a small charge of electricity. So if you throw a little more charge in, it has an impact. Wow, it's just one little strand hanging on there for dear life. Okay, on the 50 volt setting, what does the eye do? Closes right up. Not going to open. This could also be implicated in the motorboating effect. This is the capacitor that's filling up and emptying out, in a sense. That's causing the fill up, empty out, pot. That's could be because of this guy. Okay, so we're going to put a new 0.05 in there, and then we're going to test the radio after that. 0.05. Okay, we're ready for a test here. Let me just make absolutely sure. A little tidbit of wire there. There we go. Okay, we're ready to try it out. Last time this didn't work all that well. I don't really know why. As I say, it could have just been something in the way I'd set things up. Didn't realize. Everything looks good though. Okay, plug it in. Switch is on. The power's not on yet. The switch is on. Go up about there. Okay, here we go. Now watching the dim bulbs. The bulb you can see. Interesting that it doesn't get brighter right away. That's interesting to me. I would have expected it to get a little brighter there at the start. It's probably because I have two bulbs in, come to think of it. Heard something there. Ooh, that sounds good. Oh, could it be we have more volume? Okay, think I'm on the broadcast band. Don't really know for sure. Antenna's connected though. We're at the high end. Swooshy sounds. Don't want those. That swoosh.
What's the rationale there for selling it off? Is it just the Trump tweet?
I have no idea. So I actually reached out to, in the 9 o'clock hours, talking about it and just sort of reporting the headlines.
This is running with 88 volts.
Person out in San Francisco said that it is something that I emailed one of my best trading sources.
So that effect you're hearing right now is regeneration, I believe. There's regenerative feedback in the radio somewhere. So I'm pretty sure there's an oscillation rate in the IF circuits. They are producing their own tone, I believe. And what you're hearing is the heterodyning between the internal oscillation you cannot hear and another similar signal coming up, frequency close. The separation between them reaches audio range and you can start to hear it. That's not the best explanation, but it's picking up stations left and right though. These are all local stations within 100 miles or so of where I am. Yeah, I don't know what to make of that that tone. That's why do we not pick up stations here? Am I reading this wrong? Am I reading the wrong? No, outside is the AM band. So most of the local stations are in this area, and there's usually nothing much happening up here. Where are they? Where are all those local stations? Well, then what am I doing picking all this stuff up here? This, maybe the alignment is just horrible on here.
Hilton Head Island, South Carolina. These are golf courses that literally have.
Into this year, we don't know that. But if I'm correct, if it has continued into this year based on the selling pressure, maybe for whatever reason it's on pause today, or maybe it's done.
All right, Abigail, great stuff. Really appreciate it. Thanks so much, Abigail Doolittle, joining us there. All right, guys, let's flex the muscles. I know one person who has definitely seen the Oscars, and that's Peter Ranganathan, Bloomberg Intelligence Analyst for U.S. media. Have you, Peter?
If I had to guess, I'd say that's 740 kilohertz. No, it wouldn't be 740, it'd be 1130. I guess it's around 1130. I'm trying to remember the stations and. It wouldn't. Well, that's curious. That's very curious. It almost seems as if the low end is up here, but I don't think so. For some reason, we're not receiving where the strongest stations are. Instead, we're receiving where weaker ones are, and they're coming in pretty good. So it's good and bad at the same time. So it could just be alignment issues and nothing more than that. Once the alignment is performed, this may all clean up. Let's go up on the short wave band now. Short wave band is here. Okay. So at the low end, 6 megahertz, 8 megahertz, you should start getting stuff in this area here and all the way up. That's how and nothing down in this low end. It's wrong time of day for that. Okay, start getting stuff anywhere here now. Anywhere here now. Somewhere.
He shall take you and shall show it. Locked to on this passage. Those of you will think, yeah, this is a pretty heavy persecution being described here. They're going to need to be comforted. But there's more. Let's hear it again. I have yet many things.
This is probably the image of what we were listening to. Image is a undesirable radio effect that radios take steps to minimize. The same station in two places close together. It's Radio Marti, which is an American radio service in Spanish.
And what he was reading,
Tone.
it was supposedly a book of Right. And it was by a Baptiste. I think I read quotes from him. When I read or hear these things, whether it's from this gentleman or from
Getting up towards 15 megahertz now.
Blessed is the one
Ucrania, la sabiduría y la cultura orientales se tratan con un cariño sorprendente. En algún...
Stop it. Blessed is the one who endures under trial.
So this is yeah, I was reading the wrong scale here. This is ham radio, FT8. They do 15-second bursts, then a couple seconds of silence, and then another burst of that weird stuff which you can't hear right now. Let's wait for the next 15-second burst to come. There it goes. 15 seconds with 50 ham guys doing that, and then the next 15 seconds it's a different 50 ham guys doing it. Then we're back to the first group again, and these two groups are kind of communicating. Something like that. It's a terrible explanation. I'm full of terrible explanations. FT8. What's this? I don't know what that is.
En febrero de 2022, pero en cualquier caso, mi diario continuará siguiendo la lucha de Ucrania por la libertad y la reconstrucción.
And it screams like a leopard caught in a trap. You put this bar of hot steel and it lets out a scream heard all over the shop. And the slag will bubble up to the top, going through the fiery trials of life, our lives. Shit.
The fiery trials of life. There's the FT8 again at a different frequency, I think. Well, that's interesting. So we're picking up WWV now. 15 megahertz is right here. That's where we should pick it up. We're just a little off. So WWV is a time signal from the United States, from Boulder, Colorado. Been listening to this my entire life. Okay, we're going to keep going though. I've done this whole thing with 88 volts on the radio. No idea what that is. There we go. That's a big one there. 9.3. And we shouldn't pick anything up here. Okay, so I'm going to stop now and consider my next move here with the radio. It's working quite well. It's working quite well. Although broadcast band's a little odd that it doesn't seem to want to work at the lower end. So yeah, think about this a little bit. Okay, in the top right corner is my SDR screen. Let me turn on the SDR. The radio's not operating right now. The SDR antenna pickup is this coil. It doesn't pick up very much, does it? But you see some kind of reaction there. That's a little better. Okay, was expecting a bigger reaction, but we won't worry about it. The objective here is to detect the local oscillator in the radio. There'll be a certain amount of energy coming out of the radio at the local oscillator frequency. Pick it up with the coil, see it on the SDR screen, and the height of the line will tell us how strong a signal the local oscillator is. And put this coil somewhere where don't move it. And tune the radio. The local oscillator frequency will change, but its strength should not go down. I suspect it's falling off and disappearing as we get to the lower end of the AM band. That's what I want to find out by doing this. So we need the radio to start off at the high end where it was working. And I need to put this somewhere near the local oscillator coil where I can leave it undisturbed. So I think what I'll do is just kind of clip it in this area here. I think that's going to work. The main thing is it doesn't get disturbed. We'll see. When I turn the radio on, we can watch the SDR and we'll see what signals pop up. In fact, I'll put the SDR full screen for that. Okay. Here we go. I'm turning on. Okay, radio's plugged in. Switch is on. Volume's up just a wee bit. Power is being applied now. Watch the SDR and see what it does as the radio warms up. I'll put the volume up a little bit here too. Okay. You see anything happening yet? Nothing going on. Ooh, there we go. Okay, so that thing that popped up on the far right, that's the local oscillator of the radio. Radio's tuned to the high end. It's tuned, I'm looking at it now, it's tuned to about 1600. Let me turn it down. So if it's tuned to 1600, which is way out here, top of the band, the local oscillator should be 450 kilohertz above that, roughly. So if we take 1600, add 450, what do you get? You get 2050. So it should be 2000 should be right about here. So you see it's just a wee bit off. Okay, that's fine. So that proves that that is the local oscillator. I'm going to tune the radio. You're going to see the this frequency shift, and we're going to watch the height of it as we get down towards the bottom of the AM band, which is down around here. So this will only come down to about here, and then it just doesn't go any lower. It shouldn't go any lower. Frequency wise, let's see what happens to the strength of it. So I'm tuning up, so it's going up. I'm going to tune down. You have to give the SDR a chance. So it's going up to the minus 30 dBFS, whatever FS is. Minus 30 dB. Okay. Minus 35 dB. Minus 40, no, 40 something. So that's, oh, where'd it go? What happened to it? Okay, I'm tuning back up, up, tuning up. At some point it'll kick in again. Let's see what it happened. Oh, there we are. Kicked in there. Now if I tune down, look at, oh, can't go down at all. It won't oscillate anymore. So that's why I'm not hearing anything at the lower end of the band. The local oscillator is failing to oscillate. Go up. Am I not going up? Yeah, I'm going up. Way up. What happened? I'm going down. I was going down, for crying out loud, because the scale is backwards on this radio. Okay, going back to the air. There we are. So it's quite consistent. It just quits right here. It just can't do it. So it's having trouble operating at the low frequency. But you would think these things have trouble at the high frequency, which they do. Oh, let's check that. Okay, so I'm going to switch bands now. This is a little more difficult to check. Okay, now interesting enough, I'm going to tune the radio. See, there are signals flying around where they shouldn't be. There shouldn't be any signal on the screen. But it doesn't really matter because the radio can't hear any of that. So right now the radio is tuned to like 18 megahertz. So we got to go up. We got to go way up to around 18 megahertz. 18. So something here, probably this, is the local oscillator now. So I'm going to tune the radio and the local oscillator. I'm going to tune it down in frequency. And okay, so there you see the local oscillator moving back and forth. I don't know, is that really it there? Because it's really ripping. But then, okay, so we reach the top, and it doubles back just a wee bit. Now, last radio I did the same thing too. So now I'm tuning down. You see it went up at first, now it's going back down. So it does something funny at the top. Probably the capacitors, capacitance, it gets a little out of control when you reach the end of the capacitors. Meshing or unmeshing. Okay, so we're now not very strong on here, is it? Where'd it go? It's very weak. Okay, we're going to go down to the other end of the band now, which is around 6 megahertz. So I'm going to drop this down to 6 or so. 6. Okay, I'm going to tune the radio way down. Look at all the weird stuff happening here. Going past stations on the way. We're watching for the local oscillator to appear. Here it comes. Now, any doubt about that? Look at the strength of it. Wow. Okay, it's a monster. It's a monster signal. So we're going right down to the end of the band here and see if it does it do the same thing the AM did. Let me move this over. I'm just sliding it all to the right. Let's keep tuning down. Down, 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 down. Okay, we're getting down to the end here. Is that capacitors bumping into something? What's going on? Well, there's nothing weak about it. It's weak at the high end, not at the low end. So it's, you know, the local oscillator is weak at both extremes, I would say, the high and the low. And that's not too surprising if you think about it. They're trying to stretch this oscillator to operate across this great range of frequencies. That's pretty challenging. So it wouldn't be too surprising if things were a little weak at the ends. But not so weak that it fades out. That shouldn't happen. So, okay. Let me flip back here. You know what just dawned on me? For crying out loud, I'm operating the radio with only 88 volts. Have you been yelling at me about that? You should have been. So let's try this again with full voltage, because maybe that's all that's happening here. Is I've got the radio operating with not its proper voltage. So we're in the broadcast band, and we should see there's the local oscillator. See, it's still quitting. Right there. It went away. Let me move the red line out of the way here. Okay, we'll go back up. Okay, let's give this guy some more voltage to work with. It's probably going to get a little louder too. I'll bet you it works now. I bet you it was just me being stupid. Okay, here we go. Going down. So there, all the stations are there now. Something funny happening at the bottom here. Something to do with the string or something. But all the stations are there now. So that's all it was. It was just me. In fact, this radio is like 2 thumbs up here. It's working really, really well. Let me get this out of here.
You can expect delays in the area. Bay Street is closed from Dundas to Albert for the ongoing investigation.
And also happening right now, we have got a power outage that is happening in East York. Nearly 5,000 homes and businesses are without power along Mortimer Avenue between Broadview and Pave. Thermal Hydro says the boundaries are from O'Connor to Browing and then DDP to Pave. Now it's still like...
So they're talking about a power outage in the city of Toronto. They mentioned Toronto Hydro. Hey, that used to be me. When the power went out, I was not involved in the group that went out to try to restore the power. I was the guy who came along later from the engineering department and went, hey, what happened here? Yeah, it's only if it involved an underground power cable. If it was overhead lines, you know what, we know what happened there. Raccoon, tree limb, I mean, you know, ice. But underground, different matter. 2,000 kilometers of underground high voltage power cable under the streets of Toronto that I was responsible for. Yeah, pat myself on the back. Me and another 1,000 people. Okay, let me stop here now. I don't have to stop. I think I'm done for today. Tomorrow we'll look at the alignment of the radio, and which seems to be pretty good. It's working pretty well, so I don't expect it to be too far out. And then we'll make a decision about testing the tubes or not. Why bother testing them if the radio is working fine? That's, you know, what are you looking for? Great. Great. I think it's great. I think it's come along great. Okay. See you on the next video.